Hello and welcome to another Ginger Mathematician video where I'm going to go through a long video here on IGCSE questions on trigonometry skills. So if you really want a crash course in how to use the sine rule, the cosine rule, using SOHCAHTOA in a long extended kind of question, then this is the video for you. Before I get started, then do think about liking and subscribing. This has come directly from my channel, so I sent out a poll and said what kind of video do you want me to do in my all of series, and the very first thing that came up was sine and cosine rule. So let's get started and do some of these questions. Now remember, you have a formula list, so we're going to use these formulae at the bottom a lot. So the sine rule, the cosine rule, and the area of a triangle. So I will be coming back to this through these questions. Okay, so let's get started on question 7. So AB is a vertical tower of height 30 meters, and they give us a nice diagram here. And they give us an angle, BCA is 68 degrees, and BD is equal to 36 meters. And we need to calculate AD. Now, one of the things I notice students do is they look at this kind of question, they go, right, I have to use trigonometry. I need to use trigonometry. But let's consider this a bit more carefully. We actually have here a right angle triangle. This has got a 3D representation, but it is still essentially just a 2D right angle triangle. So I'm drawing this over just so you can see what I'm highlighting here. And if I draw this in 2D, so if I just do a very quick 2D sketch, not to scale of course, then notice this here is 30 meters, this here is 36 meters, and then we're looking for this side here. Once I draw it like this, then actually we don't need trigonometry here at all. Despite the title, we can just use Pythagoras. Now, the way I recommend to Year 11 students is that you can get the 2 method marks here with a very straightforward calculation. We can do x equals, we're going to go to square root of 36 squared minus 30 squared. So we can write this as one very smooth calculation. If you want to use Pythagoras directly, then we could write this as 36 squared equals x squared plus 30 squared. Rearrange this so we get x squared equals 36 squared minus 30 squared, and then do x is equal to the square root of 36 squared minus 30 squared. We want to show all those steps in working. But if you look at the mark scheme, you'll see that this is perfectly adequate to get the 2 method marks. Now, once we've got that, then we're going to have to work this out on our graphical calculator. So we type this in, so control this button here for the square root, 36 squared minus 30 squared, press enter, and then we get our answer of 19.89. So I'm going to write that here, 19.89 ... And remember, for all these questions we're going to do here, we always round to 3 significant figures. So this is the first significant figure, second significant figure, third significant figure. So we draw our line afterwards, and then the 9 is going to round the 8 up to 9. So we get our accurate answer here to 3 significant figures, as we should always do, of 19.9, like so. And once we've got that, then we're going to calculate the side AC and show that it rounds to 12.1 meters, round to 3 significant figures. So they often like these show questions as part of trigonometry, and this is a good example of this for 3 marks. So if we go back to our diagram, the side that we're looking for this time, let me put this in black here, is this side here. And again, we've got another right angle triangle. So if we draw a sketch out like so, where this is a right angle, this is 68 degrees, and this is 30 meters. Notice we now do have a situation where we can use trigonometry, and more specifically, we can use SOHCAHTOA. Now, if we're going to use SOHCAHTOA here, the first thing we always do is label the sides. So this is our longest side, this is our hypotenuse. This here is opposite the angle, so we're going to put an O here. And this here is the side we're actually looking for, so I'm going to call it X in this case. And this is the one that everyone forgets. This is the adjacent, so the side next to the angle. And now we decide which side that we have and which side that we're looking to find. So get the highlighter out here. We are looking, well, we have the opposite and we're looking for the adjacent. So in that lovely acronym we like to use, SOHCAHTOA, which one has O and A in it? Which one has OA in it? And that would be the last word that I mentioned there, which is TOA. Now, what does that look like? Well, this is where I draw a formula triangle with a pen, of course. So here's my formula triangle. I recommend you use this method. We have tan theta times A and O. So you need to know these three formulae triangles we're going to use through these problems. And now because we are looking for the adjacent, so we're looking for the adjacent side, imagine that's crossed out, we're going to do the calculation O divided by tan of the angle. Okay, so what does that mean in this question? Well, we're going to do 30, that's our opposite, divided by tan of the angle, that's 68. So in order to show our calculation here, AC is going to equal to what we just wrote, 30 divided by tan 68. And let's go over to my calculator and work that out. So before you do anything with trigonometry here, make sure that it says DEG at the top for degrees. One of the biggest mistakes, particularly international mathematics students, 06, 07 students make, is on their graphical calculator. They do not check that it says DEG at the top and not rad. Okay, notice you can click and it can go between the two. So once it's in DEG, we are going to get the correct answer. At this point, we type in, so 30 divided. Now to get the tan function, you can either type in TAN, or you can press the trig button and you'll see they're all here for you. So tan 68, enter, and we get our answer of 12.12. So we're going to write that in. So 12.12 dot dot dot. And if we then round this to three significant figures, like we've done in previous questions, we get 12.1 meters to three significant figures. And I like these kind of questions because it's one of those show questions. So in the exam, I can guarantee I've got all three of these marks because I've written the working needed and I've got to the right answer that they've indicated to me in the question as well. Feel free to have a look at the mark scheme so you can see where you pick up those method marks. Notice I picked up the M2 mark here for the first question by writing it in one very quick calculation. So I'm trying to save myself time through a very stressful exam, whether you're doing the paper 4 on 0580 or on 0607. It's still a good way of getting those method marks efficiently and giving yourself more time for other questions. Alright, and let's continue on to a more difficult style question. Now notice when you get a question number here on paper 4, with this is question 11, question 12, towards the end of the paper, they generally are on the harder side. Whereas you're going to see later on question 3, that'll be a slightly easier style question. And we've got a triangle here, and we need to use the cosine rule. So we'll go back and check what the cosine rule is to show that this quadratic is true in some way. So we've got quite a lot of work to do here because it is out of 4 marks. And let's just remind you what the cosine rule is. So it's equal to c squared equals a squared plus b squared minus 2ab cos c. Now remember the formula sheet actually had the letters in a different way around. But let me just show you how these letters correspond to my diagram. So the angle is going to be big C. So this one here. The side opposite big C is going to be small c, and then the other two sides, it doesn't matter which way round, are going to be A and B, like so. So now I've labelled the sides, I can now substitute A, B, small c and big C into my formula. So I'm going to copy out the formula. Wherever I see a small c, I'm going to put a 9. Wherever I see a small a, I'm going to put a 3x minus 1, and so on. So let's do that now. So we get 9 squared equals a squared is 3x plus 1 all squared plus, and this be very careful with brackets here, so 2x all squared because we're squaring the whole of 2x here, minus 2 times, well, a is 3x plus 1, so 3x, so minus 1, sorry. Can't read my screen, that's not very helpful. Good, I'm always checking these things though. So 2x times the cosine of the angle, well, the angle is equal to 60, like so. So let me change this, because this should be a -1 here. So that's important. And now let's work some of these things out. Well, 9 squared is equal to 81, so that's fine. 3x minus 1 squared. Now remember, that's the same as timesing it by itself. So 3x minus 1 times 3x minus 1. And now we're going to use FOIL. So that's first, outside, inside, last, to make sure we multiply it out correctly. So 3x times 3x is 9x squared. 3x times minus 1 is minus 3x. 3x times minus 1 is minus 3x. And then minus 1 times minus 1 is plus 1. Make sure you're very careful with that last one there. If we collect up the like terms, then we get 9x squared, that stays as it is, minus 3x is minus 6x, and plus 1 stays the same. So let's pop that in now. So 9x squared minus 6x plus 1. Now 2x all squared, remember that's the same as doing 2x times 2x. And that's equal to, well, 2 times 2 is 4. X times x is x squared. So let's pop x squared here. 4x squared. And now let's neaten this out. So here we've got 2 lots of 3x minus 1 multiplied by 2x multiplied by the cosine of 60. Now this is one of these exact values that you should know off by heart. Of course you can always use your calculator to check this as well, but the cosine of 60 is equal to a half. Now on a calculator paper this is obviously not that important. Let me just quickly show you. So trig cos 60 is equal to a half. So you can see you can use your calculator, but if you know them, it will speed up the process quite significantly. So no, times a half, like so. Let's keep simplifying this down. So 81 I'm going to leave alone for the time being. Notice we've got a 9x squared and a 4x squared, so that becomes 13x squared minus 6x plus 1. And now we're going to work out the bracket. So we'll do this in stages. Well, 2 times a half cancels, because that becomes 1. So these cancel. So we're left here with 3x minus 1 multiplied by 2x. Just take it one step at a time. And let's keep going. So 81 equals 13x squared minus 6x plus 1. And now we're going to expand the bracket. So I'll do this separately here so you can see what's going on. So remember, expanding a single bracket, we used our single hook, like so. So 2x times 3x is 6x squared. 2x times minus 1 is minus 2x. So let's pop that in, and this minus here is very important. So we need to be very, very careful how we deal with this. And we're almost there, So once you see this next step, you'll see we've almost got to the answer. So we get 81 equals 13x squared minus 6x plus 1. And now we're expanding essentially a single bracket here as well with this minus. So we get minus 6x squared. And this is the thing really to watch out for in this question. The minus times a minus is a plus. So we get plus 2x. Oh, almost there. So 81 hasn't moved for the time being. So 13x squared minus 6x squared is 7x squared. Minus 6x plus 2x is minus 4x plus 1. And this is where you're feeling quite confident because this looks almost identical. Let me just put the final answer up here, a bit of space. So I'm going to flip over the equation. So I've got all the x's on the left hand side. And to get my very final mark here, well, I want to have the right hand side 0. So what's the opposite of adding 81? That's minusing 81 from both sides. This is really satisfying when you get to this point. And you get 7x squared minus 4x squared plus 1 minus 81 is minus 80 equals 0. And the great thing about this is I know I've got the right answer. You see this, you see that, and then you go, Yes, I've done it. I've got those 4 marks in the bag in this particular question, which is a pretty tricky question. It's certainly going to be grade A for this kind of algebraic manipulation. So you can have a look through the mark scheme. The mark scheme is not very useful here because it doesn't show you all these intermediary steps that I did in the middle. So this is why these kind of videos are very, very useful. You can see exactly the process I've gone through to work out the answer. Right, let's move on to another question 11. So 2 question 11s. And in the diagram, ADC is a straight line. Now that is important a bit later on. The first thing we need to do here is calculate AB. So as soon as you see this right angle triangle, you need to be thinking Pythagoras or trigonometry. Here we have one side and one angle, looking to find another side. So trigonometry is called for. Once we know it's trigonometry, then we have to label our sides. It's our first step that we do. So this here, this new x is opposite the angle. So this is O. This 8 here is next to the angle. So I'm going to put an A here. And again, we use SOHCAHTOA. So which of those has an OA in it? Well, that's going to be tan again. So we're going to use tan twice in this video so far. And again, we need to know these formula triangles. And this time we are looking for the opposite. So this is the thing that we don't know. So we cross out this part here. And then we're going to do the calculation we see, which is tan of the angle times adjacent. So to work out AB, we are going to do tan 34 times 8. So I've shown my calculation for the method mark. Let's go to my calculator and work it out. So we're going to type in, we can use TAN or we can press the trig button, tan 34 multiplied by 8, enter, and we get our answer of 5.396. So I'm going to write down 5.396 ... Again, we want to round, as always, to 3 significant figures. So 1, 2, 3. We round the 9 upwards, so that's going to give us 5.40. Again, we have to be very precise in the rounding that we do to guarantee that we get all the method marks. Now we need to work out the angle DBC, and it's a whopping 5 marks, so you know there's going to be quite a bit of work involved in order to work out DBC. Now, how do I know where DBC is? Well, the middle letter always tells me where the angle is, and the sides tell me, okay, how do I get there? So DBC is going to be this angle that we're looking for here. Now back to my point here, ADC is a straight line. Therefore, I know that these 2 angles, so this angle plus this angle, add up to 180. So to work out this angle here, I'm going to do a very quick calculation of 180 minus 34, and that's going to give me 146 degrees. So I'm just going to pop that in. Again, always use a calculator if you're not sure about that calculation. And then we look at the problem here and go, well, we've got a side and an angle. We're looking for this particular angle here, but at the moment we can't work that out directly. However, we can use this side over here. We can use this 8 to help us work out this one. So if we go through the process again, we have an angle and a side. We have a side and then a missing angle here. What does that call for here? Well, there's no more SOHCAHTOA, there's no right angle triangle, so we're going to use either the sine rule or the cosine rule. This is a situation for the sine rule. Now, what is the sine rule? Well, this is on your formula sheet. Sine A over A equals sine B over B. So we just need to label this up correctly just so we know which one is which. So just to stop any confusion here, I would rub that out, but I can't. So let me use a different color. So we're going to make this our big A because we know we're going to make the angle that we don't know big A. So they're going to make this one big A. This makes this then small a, and then we're going to make this big B and then make this small b. If we label it correctly, it makes the working we're going to do just now a little bit easier for us. So let's go through this process. So we've got sine A divided by the side opposite it, so that's the 8 over here. and that's equal to sine of the angle here, so that's sine 146 divided by 19. And generally when I have this kind of problem, we want to try and get the a on its own, or the sine a on its own. So we look at the left hand side and go, well, what's the opposite of dividing by 8? Well, we need to multiply by 8 on both sides. This has the effect of cancelling here. So we get sine a is equal to, well, 8 times sine 146 is exactly that, divided by 19. And we can simplify this slightly further before we actually go on to use our calculator. So then we have the sine of the angle. So what's the opposite of sining? Well, that's going to be the inverse sine. And remember, we do that to both sides. So that's going to give us a, because this part and this part cancel. And so we get the sine inverse of 8 sine 146 over 19. And notice I haven't rushed to my calculator here until I've got it in a form that I like, and try and minimize any of those rounding errors as we go through the problem. So I'm going to go to my calculator and work this out. So where is the inverse sine button? Well, all you have to do is go to trig here, and you'll find there's a sine minus 1 button under here. So that's where our inverse sine function is. To make a fraction, we just go to control and divide. That gives us our fraction. And then we just type it in. Notice I can type in sin and it will recognize the function. Do love this TI Inspire calculator. And put 19 at the bottom. If we work this out, we get the angle of 13.618. So let me write that in. 13.618 dot dot dot. So that's the angle here. 618 dot dot dot. Now, of course, that is not the answer that we're looking for here. We are looking for the angle DBC. But now we can use the idea that angles in a triangle add up to 180 degrees. So to work out this final angle, so DBC, we just do 180 minus the two angles that we do know, so 146 plus 13.618 dot dot dot. Again, trying to avoid those rounding errors by keeping as many decimals in as possible. So let's go back to my calculator. So all I'm going to do here, I'm going to do 180 minus, open brackets, 146 plus answer, so control answer. This allows me to get the most accurate answer possible for this particular question. So if I work this out, I then get my final answer of 20.38. 20.38 dot dot dot. And of course, we always round to 3 significant figures. So our final answer will then be 20.4 degrees for our 5 marks. Now, I think maybe this should be a 4-mark question personally, but again, there's quite a lot to consider here. First of all, the angle's on a straight line, then using the sine rule for an angle correctly, and then realizing we need to use angles in a triangle to find our very final answer of 20.4. Now, we're going to use this a little bit in the next question as well. So now we need to calculate the area of triangle ABC. Now, just keep in mind here that the triangle ABC, so if I do this in a different color, let's do some yellow, is the entire triangle that we see in front of us. So it's this part, and this part here. So we try and find the whole triangle together. Now the easiest way of doing this is to use that formula from the formula sheet that we haven't mentioned yet. So the area is equal to a half AB sine C, where A and B are two sides and the C angle is in the middle. Now the one that comes to mind here is to use some of the things that we already have. So I'm going to use this big angle here as my angle in the middle, my C. X we already worked out from the previous question, 5.40. We know 19 from the question itself. And because we worked out this angle, notice these questions lead into, we actually know that this angle here, the whole angle, is going to be 90 plus the answer we just worked out, 38 dot dot dot, which is going to be equal to 110.38 dot dot dot. So let's bring all this together for our formula. So the area of the triangle, I'm just going to write down to the examiner that I know what it is, half AB sine C. And let's just pop in all the numbers that we have. So a half times, well, we know what x was. That was the 5.396 dot dot dot. We know that the b side would be 19, so times 19, and then times the sine of the angle in between. So that's 110.38 dot dot dot. Notice with this kind of question, they are usually quite lenient in if the answer is not exactly accurate, they'll still give you all 2 marks. Let's try and make it, though, as accurate as possible. So we have 0, oops, there we are. So 0.5 times 5.396. Probably should be using a few more decimal places, but we'll use this for the moment. 19 times, and we want to use sine here, of 90 plus answer, because the answer from before was that smallish angle that we had. So I'm going to try and use that just to minimize any rounding errors. So I think we've got everything there, and then we get to our final answer of 48.052. 48.052, and that rounds then to 48.1. So let's just check the mark scheme and make sure that's accurate enough for the mark scheme. Yes, it is. You can see actually it should be between these two numbers. So both 48.0 or 48.1 is correct. But the best thing to do is try and keep as many decimals in the question as possible, just so you don't miss on any accuracy marks at the end. Notice with the mark scheme here, they give you a range to get it between. So 48.04 and 48.12, which we certainly fit into with our answer of 48.052. So again, try and keep those questions as accurate as possible. Right, on to our next question, so question 5. So the area of the triangle ABC is 34.1 square centimetres. Now as soon as I see this, I know that formula we looked at in the very last question, half AB sine C, is going to be useful in some way. We're given AB is 12.4, angle ABC is 30, and now we need to show that BC is equal to 11. So we're looking for this side here. So what I'm going to do is just use that area formula that we have. So area is equal to 1/2 AB sine C. And now let's just put in what we know. Well, these are the two sides A and B, and this is the angle in between, so C. So if we substitute this in, well, 34.1, that's our area of the triangle, is equal to 1/2 times, well, A is 12.4. B, we don't know, that's what we're looking for here. So I'm just going to call this X, because that's the side we're looking for, times the sine of the angle in between, sine 30. Now, I could simplify this down because sine 30 is 1/2, and you can find half of 12.4. But what I'm going to do here is just let the calculator do this for me. I want to get the x on its own, so I need to divide by 1/2 times 12.4 times sine 30. Basically, I want all that on the other side of the equation. So divide by 1/2 times 12.4 times sine 30. If I do this, well, these all cancel. That leaves me just with x, and then I get 34.1 divided by 1/2 times 12.4 times sine 30. And now I'm going to let the calculator do the donkey work here and work out exactly what this is. So we type this in. So 34.1 divided by 0.5 times 12.4 times the sine. Always very satisfying when you put this in and you get the exact answer that you're looking for here, which is 11. So we're just going to pop that in, and that's equal to 11 centimetres, guaranteeing that 1 mark. Excellent. Now we're going to move on and work out AC. So let's have a look here. I now know it's equal to 11 centimetres, and I want to work out this length here. Let's just call that Y. So I look at the triangle I have here. I've got two sides. I've got the angle in between, and I'm looking for the side opposite. This calls for the cosine rule. Now remember the cosine rule was c squared is equal to a squared plus b squared minus 2ab cos c. And now I can just substitute everything that I know into this. So we're looking for this side, so y squared is equal to, well, a squared and b squared, so 12.4 squared plus 11 squared minus 2 times 12.4 times 11 times the cosine of the angle in between, which is 30. And remember, I want to find y on its own. So what's the opposite of squaring? Well, I do need to square root on both sides. So notice I haven't reached for my calculator yet. I'm waiting until I get to this final step. So y is equal to the square root of 12.4 squared plus 11 squared minus, open brackets, 2 times 12.4 times 11 times cos 30. And you can pick up a lot of marks on these questions by just knowing these formulae and working through these questions nice and carefully and logically. So let's pop this into the calculator and see what we get. So we're going to start with a big square root. It's going to be a big square root by the end. So 12.4 squared plus 11 squared minus, this is where brackets are really, really important, so please do include them, 2 times 12.4 times 11 times the cosine of the angle in between. Okay, hopefully that's all enough brackets there. So always double check. So checking my working here on the left hand side, checking that with what I've just typed in. I press my enter button and I get my answer of 6.21. Okay, so let's pop that across. So 5 dot dot dot. Now usually I would write this working here in this space for B. If we round this, then we're just going to get 6.21 centimeters. So, and always check your rounding for these kind of questions as well. Don't need to put units twice to get my answer of 6.21. And now we're looking for angle CAB. Remember that middle letter tells us where the angle is. So we're looking for CAB using the letters that are given in the question. So we're looking for this angle here. As soon as I look at this, I go, well, I've got a side and an angle, and now I know this side because we just worked this out. This was 6.2055 dot dot dot. So this calls for using the sine rule. So when you've got a side and angle and a side and you're looking for another angle, then we're going to use the sine rule. That's all about labeling here. So let's do a different color so you can see what we're doing in this particular question. So I'm going to call this big A. I'm going to call this now small a. I'm going to call this big B. I'm going to call that small b. Right, let's do it on this slide here. So we're going to go sine A over A is equal to sine B over B. So A we don't know, the side opposite is 11, so we get sine A over 11 is equal to sine of B, which is 30, divided by that side we literally just worked out, so that's 6.2055 dot dot dot. Again, we want to get the sine on its own, so what's the opposite of dividing by 11? Well, we need to times by 11 on both sides. If we do that, then we get sine A is equal to 11 sine 30 over that 6.2055. We're not quite done before we use the calculator. What's the opposite of sining something? Well, inverse sine on both sides. This gives us then A is equal to sine inverse, and then everything in that fraction. So 11 sine 30 over 6.2055 dot dot dot. Remind me to try and use as many decimal places as possible. Let's go and see what the calculator says. So we start with trig sine inverse. Open up our fraction. So we have 11 times sine 30, close brackets, and now I can use the answer from the previous question. So I can go control answer. That will then take this answer here that I've just used. Let's make sure there's brackets there, and then we get our answer of 62.413. 62.413, and that rounds then to 62.4 degrees. If you check the mark scheme again, that falls within that range that we've looked at here. So that's absolutely fine. Notice I do try and keep it unrounded when I can, because it does give you the most accurate answer in case there are any problems with the accuracy there at all. Now my last question is to find the length of the perpendicular line from A to the line BC. So this is a slightly different kind of question here. So let's go back to my diagram. So imagine I drop a perpendicular line from A to the line BC. So from A to the line BC. So this is what they mean. Imagine this is perpendicular. Now, as soon as you see that word perpendicular, you know that there are right angles there. So perpendicular, diagram's getting a bit messy now. Basically means they meet at a right angle. Okay, so what I like to tend to do in these kind of questions is separate the problem just so I can see what's going on. So what I'm going to do is draw this triangle at the top here with the information that I know. So I'm going to rotate it round. Okay, so that's my right angle here. I don't know this length, this is what I'm looking for. I know the hypotenuse because it's opposite the right angle is 12.4. And I know that this angle here is 30, which is over here. So I've just done a quick 2D representation of exactly the triangle I'm looking for here. And once we know that, then we can simply use SOHCAHTOA, our classic. So let's get labeling those sides. Don't know why I put a degree sign there. There we are. So this is going to be opposite because it's opposite the angle. This is the longest side. And this time we're not going to use tan like we've done before because we've got O. So of SOHCAHTOA, which one's O? Well, that's going to be the SOH. So if we draw our formula triangle, we have sine theta times H and O. So we need to know these formulae triangles like literally off by heart. We are looking for the opposite. So we're going to do sine of the angle times H. So our answer for X is going to be sine 30 times 12.4. And you'll see that is 6.2. Now, how do I know that's 6.2 without using the calculator? It's because I know my exact values. So I know sine 30 is equal to a half. So it's just a half times 12.4, which is just equal to 6.2. No rushing to my calculator for that particular question. And again, I really do recommend if you need to know those exact values, then do check out the link just as you see above, because that goes through exactly how to work out sine 30, sine 45, cos 60, tan 45, and so on. So here's the mark scheme. Again, you can have a look and see what I've done and where I've picked up all the method marks for these particular questions. Okay, and on to question 3. So it's going to be a little bit more on the easier side here. So on the diagram, BCD is a straight line. Again, important because we've seen that in previous questions. And the first thing we need to do here is work out the length of AC. So notice we've got a right angle triangle. So SOHCAHTOA should be in your mind. The first thing we're going to do is label those sides. So this side I've just done in black here is the hypotenuse. This here is the opposite the angle. And now I think SOHCAHTOA. So O is of course in the SOH category, just like the previous question. Nice follow on from what we just did. So H and O. This time we're looking for the H. So we'll cross out this and we're going to do this calculation on our calculator. The opposite divided by sine of the angle. So AC is equal to 30 divided by sine 37. This time it's not an exact value, so let's use that calculator. So we're going to type in 30 divided by sine 37, close brackets, and we get 49.849. 849 ... and that rounds to 49.8 meters. 3 marks is pretty generous, but again, towards the start of the paper, you want to make sure you've got those fundamentals there secure. Right, on to part B. So we're now looking for the side BC. Let's have a look. Side BC. Okay, so this side here. Well, we can use the same triangle that we did before. Yep, just checking we're doing BC here. So this time this is the adjacent side. Now you could use opposite or hypotenuse at this point because we know both. I tend to use the value that I already know from the question. So this time we've got O and A, the OA. So we're going to use, in this case, the TOA, the tan. So we have tan theta times A over there. And this time we are looking for the adjacent side. So we don't want the adjacent. So we're going to do opposite divided by tan of the angle. So BC is equal to, opposite is 30 divided by tan of the angle, so tan 37. And again, let's go to that calculator. So almost identical process to what we did before here. So you get 30 divided by tan this time, so tan 37. And then we get our answer of 39.8. 39.8, so we just pop that in. Interesting, that question. I mean, we can just use, of course, tan. We could have used cosine as well if we wanted to. That seems the most straightforward method. And now we need to work out the side CD. So CD is this side here. Let's use a different color. So the way I would approach this, because we already know this side, because we just worked that out, this was 39.8 dot dot dot, which we'll come back to. What I'm going to do is work out the length of this entire side, going all the way along. And now I can use basically the same calculation because this is now my big adjacent side. So I'm going to do exactly the same calculation as before. So to work out BD, I'm going to use 30 divided by tan 26 and do that on the calculator, and then I can just take BC away from BD to work out CD. Just to show you my working here, CD is going to be BD minus BC to then find the final answer. So let's get the calculator involved now. So I'm going to do a nice little trick here. I'm going to store the answer as A. So every time I type in A, I've got that 39.8 ready for the next question. Now I'm going to work out what I just typed in there. So 30 over tan 26. So 30 over tan 26 gives me a bigger side. And then I can just do answer minus A, and then that will give me my direct answer here. So let me just write in these things. So 30 over 26, that's 61.5-ish, dot, dot, dot. And then my final answer being 21.69, dot, 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 which then goes to 21.7 meters, like so. So note I'll use the functionality of the store function just to help me avoid any rounding errors whatsoever. And now for question D, they want to work out the area of the triangle ACD. So they want to work out the area of, okay, the smaller triangle. So that's worth highlighting here. So in this case, they want the area of this triangle. So as soon as you see area of triangle, you need to be thinking, I want something to do with half AB sine C. And what you want to do here is see if you can use any sides that you've already worked out. Well, we worked out CD just here. This is a bit bright yellow. Let's use a different color. So CD was equal to that 21.69 that we did. That side here, so that hypotenuse, that was from part A, that was the 49.849 dot dot dot. And we know the angle in between. Because angles on a straight line, again, got a straight line here. add up to 180 degrees. So this is going to be equal to 143 degrees. And now we can use everything we just talked about to work this out. So the area of the triangle is equal to a half times, well, these two sides, that 49.849 dot 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 times literally what we just worked out, so 21.69 dot 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 times the sine of the angle in between, which was 143. Just showing my working. Now I haven't used too many decimal places here, so let's see if we get the exact answer they're looking for. So we're going to do 0.5 times 49.849 times the answer we just did times the sine, trig sine 143. That gives us 325.46. Perfect. Dot 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 dot, and then that gives us then to three significant figures 325 exactly. Popping that answer in there. Right, so you can have a look at the mark scheme, so you can see any answer between 325 and 327 is valid there, and all the method marks that we picked up going through that question. If you look at that question, you've got 3, 6, 9, 11 marks. So in terms of the actual paper, that's probably about 8-9% of your paper, just by doing this particular question here. And this is one of the best ways to improve on IGCSE questions by topic. Really, just today we're just practicing trigonometry, getting really, really good at it, seeing lots of different styles of question, and it really does help with your general understanding of this topic. Right, and let's move on to question 9. So the diagram here shows triangle ABC, and now we need to use the cosine rule to find angle ABC. Now the bad thing about the formula sheets compared to other courses is they only give you the one for a side. So c squared equals a squared plus b squared minus 2ab cos c, which is not very useful when you're actually looking for an angle. What I'd recommend is actually to learn the angle formula off by heart for your exam. Now the angle formula is a rearrangement of this. Now I'm not going to go into this in detail on this video, but we can rearrange this formula to give us this instead. So a squared plus b squared minus c squared, all divided by 2ab. I recommend you learn this off by heart, then we have less pressure in the exam in having to rearrange a formula under pressure. So please do learn this. Once you know this, this is simply a case of substituting into the formula. Now we're looking for angle ABC. So we're actually looking for this angle here. So if I label it with the letters I've got here, this would be big C, this would be small c, and then these two sides, doesn't matter which way round, are going to be A and B. Once we know that, we can just substitute into the formula. So cosine C is equal to a squared plus b squared, so 8 squared plus 6 squared minus c squared, which is 12 squared, divided by 2 lots of AB, so 2 times 8 times 6. Here we're actually looking for the angle, so what's the opposite of cosining something? Well, inverse cosine on both sides. If we do that, this cancels, always good, and so we get the inverse cosine of 8 squared plus 6 squared minus 12 squared over 2 times 8 times 6, and this is where the calculator comes in. We're going to pop it all in. So we're going to go to trig and inverse cosine. Let's set up my fraction. Once you do, a good, 45 minutes of these kind of questions, you start getting really comfortable with where the functions are, and you feel better as well of actually feeling you've really understood a topic very, very well. So 8 squared plus 6 squared minus 12 squared, 2 times 8 times 6 on the bottom. Enter, and then we get our answer of 117.27. 117.27. If we round that, then Generally, again, round to 3SF, I'd round that to 117 degrees to 3 significant figures. It's quite nice in this question because they tell you what rule you need to use in order to work out the calculation. And the next one is also similar. We're going to use the sine rule here to work out angle BAC. So remember the sine rule, sine A over A equals sine B over B. So if we go back to this now, in order to use this, we need to have an angle. So what I'm going to do is just go to my calculator now and store this. So the way I'd store it, remember, I go to Control and Store. I'm going to store it as B. So every time I type in B, I get that particular angle, so there's no rounding errors. Okay, and once I've done that, let's just now label this up with a different color so you can see what's going on here. So we're looking for BAC. So we're looking for this angle here, BAC. And notice that we're going to make this our big A. So this side opposite, the 6, is going to be our small a. And then this here is going to be our big B. This is the angle that we do know. And the side opposite the angle we know, we're going to call small b. And now we just substitute this into the formula. So we get sine A over 6 exactly equals sine of 117.27, what we just worked out, divided by the side opposite, which is 12. And you're probably used to this at this point. We're going to rearrange to make A the subject. So what's the opposite? Dividing by 6, timesing by 6 on both sides, giving us sine A is equal to 6 lots of sine 117.27 ... divided by 12. And now we want to get the angle. So what's the opposite of sining? Inverse sine on both sides. This cancels this, which is very, very helpful. And now we're going to find sine inverse of that horrible fraction. Again, using that stored value that we used before. Very, very useful function, particularly for questions like this. So let's again pop this into our calculator. So we're going to have inverse sine, control and divide. And we're going to type in 6, not equal sign, don't want an equal sign, I want a sign, there we are. Now B, remember, was our symbol that we're using to store that particular angle at the top here. And then 12 at the bottom, we press enter, and we get to our answer of 26.38. To 26.38 ... rounded, of course, that's going to be 26.4 degrees to 3 significant figures. Like so. Right, you can check the answers that we've just gone through here. That's interesting. They've wanted this to 1 decimal place, which is interesting. Usually it's 3 significant figures. So, okay, one thing I would highlight then is that they want all angles to 1 decimal place. Generally, I would think 3 significant figures is absolutely fine. And to be fair, I did show the 0.27 in the working of the question as well. Right, if you want more practice with these questions, you see I've gone through about a half PowerPoint that I've prepared today. So if you want practice by yourself and see if you really understood the concepts that we've talked about, well, you'll see there are more PowerPoint questions here. So you can really check your understanding. The link for that is in the description below, so you can go through this at your leisure and really get that practice in that you need to in order to really understand what's going on. Okay, so hopefully you found this useful, this tutorial. I think this is quite a good way of doing it. I've gone through questions here for a good amount of time to really check your understanding, and now it's your turn to go off, take this PowerPoint, go through the solutions I've done to the first part of this PowerPoint, and now really try and extend your knowledge here by practicing the questions you'll find in the PowerPoint in the description below. If you want practice on surds, then do click on the video you see in front of you.